Welcome back. This is the final video in this mini-series on augmenting econometric analysis with machine learning methods. And in this video, I wanted to talk through a couple of influential papers by Susan Athey and Guido Imbens and some others. The first paper has to do with measuring heterogeneous treatment effects. And the second paper has to do with computing average treatment on the treated using data imputation methods. This will be a very brief video just introducing these methods, but hopefully if you're interested and find them useful, you can read the papers yourself or consult other resources that go a little bit deeper. The first paper was published in 2016 in the Proceedings of the National Academy of Sciences. And this basically uses tree models to classify observations into similar groups based on the treatment effect that they would have. So if you ever see recursive partitioning or that type of language, that's referring to a tree model. And basically the idea here is that we can get treatment effect heterogeneity from a randomized experiment using these recursive partition algorithms. And the emphasis of this paper is that the inference is quote unquote honest because it uses sample splitting. So we're going to split our sample in half. We're going to use the one half to do the partitioning to organize which observations are going to have similar treatment effects. And then in the other half, we're going to actually estimate the treatment effects. So because we're not using the same data for both the partitioning and the treatment effect estimation, that's going to make this honest, meaning we're not trying to cheat or be aggressive in the causal inferences that we're making. The second paper was published in 2021 in the Journal of the American Statistical Association. And this paper uses something called matrix completion in a panel data setting to infer average treatment on the treated. And why I like this paper from a philosophical standpoint is that it recognizes that causal inference is a data imputation problem. We only ever observe the outcome under the treatment assignment that was given. So we have no idea what any individual's treatment effect would be under the alternative assignment. That's the fundamental unobservability problem with causal inference. I don't get to see the parallel universe where I got the treatment. And so this paper proposes a matrix completion method applied to panel data. And basically, this is a credible imputation technique that's been used in a lot of other settings. I think most famously in recommender systems for platforms like Netflix. And basically, we're going to look at the treated units, and we're going to impute what their outcome would have been if they were instead in the control group. And then this difference is going to be the treatment on the treated. And we can average that over all of the treated observations. And we can also extend this to take into account within unit serial correlation, since this is a panel data set. For example, you'd want to maybe account for individual fixed effects, this type of a thing. I'm not really familiar with these methods. I haven't used them myself, but they seem like really interesting methods, and they're another example of augmenting econometrics with machine learning. And so I just wanted to give you a feel for how these things are being done these days. And the main takeaway from all of these videos in this mini-series are that we need to be very structured in how we bring in these ideas from machine learning so that they won't contaminate the econometric inferences that we're trying to make. So I hope that you've found these engaging and informative, and I hope to see you in another video on this channel. Thanks.